Good morning, welcome to all. This is Tanu Gupta, Assistant Professor in Akgec Engineering College. Today I am going to discuss a very important topic in machine learning technique BCS 055, that is a reinforced learning. As we discussed previous unsupervised learning and supervised learning in machine learning technique, now we are discussing a reinforced learning technique. First, we understand what is reinforced learning. Reinforced learning is a feedback-based machine learning technique in which an agent learns to behave in an environment by performing the action and seeing the result of the action. So what we understand by the reinforced learning is a feedback-based machine learning technique. Reinforced learning worked on the feedback-based, okay, in which one of the agent could be an AI robot, or we can say a software program, learn to behave in an environment. For example, this one is a agent and this one is a environment. So an agent learn to behave in an environment by performing an action. By performing an action and seeing the result of action. The agent learn automatically with this feedback and improve its performance. So the agent automatically learn with this feedback and improve its performance. For each action, the agent get a positive reward and also an agent get a negative reward. For each correct step, it will get a positive reward, and for each negative step, it will get a negative feedback. So in the reinforced learning, the agent learn automatically using the feedback without any labeled data. Unlike the supervised learning. In the supervised learning, we have the labeled data. But in the reinforced learning, the agent learn automatically with the experience or with these feedback. It could be a positive feedback, it could be a negative feedback. If they learn a positive feedback, then it is stored in a program and act accordingly. If they have a negative feedback, then they act accordingly and do not repeat that action again and again. Since there is no labeled data, so the agent learn to bound by experience only, because the data is not labeled. We don't know about what type of data is. So the agent or it could be a AI robot, and in this case we understand learn by its experience. Whatever the agent is learned and perform an action in the environment and get a reward which comes in a positive and a negative. And the agent learn only by its experience, because the agent have no labeled data, unlike in the supervised learning. So RL is a technique that enable an agent to learn in an interactive environment by hit and trial feedback, okay, by its own action and experiences. Okay, so this is the concept of basically a reinforced learning, or we can say a reinforced learning is a type of machine learning method where an intelligent agent, could be a computer program, or we can say a AI robot, interact with the environment and learn to act within that. Okay, for example, how a robotic dog learn the movement of his arm is an example of a reinforced learning. Okay, RL solve a specific type of problem such as game playing, plane station is also an example of reinforced learning. It is a core part of AI. On the concept of reinforced learning, we do not need to pre-program the agent, because it's learned from its experience without any human intervention. So this is a main concept of reinforced learning, because reinforced learning is a feedback based machine learning technique in which an agent learn to behave in an environment by performing an action and get a positive and negative feedback, or a positive and negative reward based on a good or bad action respectively. Okay, for example, there is an AI agent present within a maze environment. Maze environment, we can say an area that is surrounded by maze environment, or it can be a football ground, it can be a playground, or it can be an environment that is fixed from the area. Okay. Or we can say a small unit. Maze environment, we can say a small unit, and his goal to find a diamond. There is an AI agent, okay, within a maze environment, and his goal is to find a diamond. Now, the agent interact with the environment by performing an action. In this case, the agent in the environment performing an action, and based on those action, the state get changed. For example, if agent is here and it perform an action, so the state of the agent is get changed from S state to S dash state by performing a some action A. The state of an agent get changed, and also it receive a positive or a negative feedback, or we can say it receive a positive signal or a penalty, or we can say a negative feedback as a feedback. Okay, the agent continue doing these three things like take action, change state, and remain in the same state. By performing an action, change the state or remaining in the same state and get feedback, and by doing these action he learn and explore the environment. Okay, the agent learn that what action lead to a positive feedback reward and what action lead to a negative feedback. As a positive feedback, the agent get a positive point, and as a penalty it get a negative point. For example, positive point +1 and a negative point -1. So by this diagram, and this is an environment, this is an agent, the agent perform an action in the environment, it will get a reward, it can be a positive and can be a negative, and back to the original state. This is a reinforced learning model, which we can say a block diagram for the reinforced learning model, in which an agent and environment, we denote an action by AT and the state by ST, and reward we can say a RT. So this is a block diagram, or we can say a diagram to represent a reinforced learning. Now these are the terms which we are going to use in the reinforced learning or reinforced learning models. For example, a Markov and Q learning and so on. So these are the terms and technologies used in a reinforced learning. First one is a agent. So what is an agent? An entity that can explore the environment. An agent is that who can perceive or explore the environment and act upon it, is a agent. Who can perform an action, or we can say who can perform an action, is an agent. And what is an environment? Environment is a situation in which an agent is present. Environment is it can be a maze environment, it can be a football ground, it can be a playground, and a situation, or we can say a situation in which a agent is present, surrounded by the RL. We assume that a stochastic environment, which means random in nature, partially observable, not random, it become a randomness in nature. We do not know, we don't know what comes in the future, what comes in the next stage. So in the reinforced learning, this is an stochastic environment. A deterministic environment is not there, in which the states are fully observable and so on. Okay, now the third one is a action. Actions are the move taken by the agent. Actions, or we can say actions are the move that is taken by the agent. For example, an agent A, it perform an transition, or we can say a move from this state to a this state to the this state. So action, what is action? Action are the moves that perform the agent within the environment. And what is the state? State is a situation returned by the environment after each action taken by the agent. What is a state? State is a situation that is returned by the environment. When an agent perform an action, it will be a particular state, and then it will perform an action, then it could be in another state. So state is a situation that is returned by the environment and after the action taken by the agent. Okay. Now comes to the term reward. Reward, it can be a feedback returned by the agent from the environment. A reward is a feedback which can be a positive or which can be a negative return to the agent from the environment to evaluate the action of the agent. The action could be a positive or action could be a negative. So reward, it can be a positive and negative. For each good action, it will get a positive reward, and for a bad action or incorrect action, it will get a negative reward. Now come to the another term, that is a policy. So policy is a strategy, or we can say algorithm, that is applied by the agent for the next action based on the current state. So policy, we can say a strategy that an agent could be followed to perform an action to change his state from current to the another state. Okay. Now comes to the another term, value. What is value? Value is an expected long-term return with the discounted factor and opposite to the short-term reward. Value, we can say value is based on the reward. Value is based on the reward. Whatever the reward, the value is affected. If we can directly toward the for achieving a final state, then the value is equal to 1. So the value is based on the reward. The reward, if there is a positive reward, then there is a good value, and if there is a negative reward, then it could be a negative value. Then the second term, what is Q value? It is mostly similar to the value, but it takes the one additional parameters, that is an action A. The value contain only a one parameter, that is a state, and but a Q value is a quality value that is more similar to the value, but it takes an additional parameter, that is what is the current state of current action of a current state S. Now the key features of reinforced learning. What are the key features? Because in the reinforced learning, the agent is not instructed about the environment because there is no label data, or we can say not instructed about the environment and what action to be taken. This is a key feature of the reinforced learning because we have not a label data. The agent is not aware about the environment, not instructed about the environment. Okay, it is based on the hit and trial process because the agent is not known about the environment, not aware about the environment. So it is completely a hit and trial process. For a good action, it will get a positive reward. For a negative action, it will get a negative reward. The agent takes the next action and changes his state according to the feedback of previous action. When an agent performs an action, it will get a positive or a negative reward. Then the other action is performed on the feedback of the previous state. The agent takes a next action and changes his state according to the feedback of previous action. If in the previous action it will get a positive reward, then the agent change its next state according to the previous state or act as an accordingly. So the environment is stochastic, means the environment in the reinforced learning is unpredictable. We cannot predict what comes next. It is partially observable and randomness. And the agent need to explore to reach the maximum possible reward. Because this is a reinforced learning, we do not have a label data. It is unpredictable about the environment, partially observable. There is a randomness in nature. So the agent learn to behave and act upon it to get the maximum reward. So these are the key features of reinforced learning. Now what is a reinforced learning problem? Yes, an agent interacting with the environment, as we are discussing, the agent exists in an environment described by some possible set of state. For example, these are the some state, that could be an agent in any of the form. Agent perform in any of set of possible action. We are denoted a capital A by a set of actions, because an agent perform a multiple set of action, so we denote the actions by A. Each time it perform an action A, some state as the agent receive a real value reward that indicate immediate value of this state action transition. It produces a sequence of a state and immediate reward, and so on. So the agent task is to learn the policy that is denoted by S tends to A, that maximize the expected sum of the rewards. So this is a main concept of reinforced learning, in which an agent has a possible set of state and possible set of action, and it perform and some action, it will transition to the another set of state. So there is a state action transition model, something like, and a sequence of state and actions and an immediate reward. Now comes to the elements of reinforced learning. What are the elements of reinforced learning? Policy, reward function, value function, and the model are the element of reinforced learning. So one by one understand what are the elements of reinforced learning. Policy, or we can say a strategy or an algorithm. A strategy used by the agent to determine the next action based on the current state. A policy is a strategy used by the agent. Policy is a strategy or an algorithm used by the agent to determine the next action based on the current state. For example, agent could be an state S. So what is the policy or what is a strategy an agent could be determined to next state action based on the current state. What will be the action performed by agent state is only decided by the strategy we can use. There are two types of policy, deterministic policy and stochastic policy. Deterministic policy is that given policy always return the same state. In the deterministic policy, is work on the experience only. For example, if we are in the state S and then we experience, then whatever we in the previous situation, what will do in the past. So in the deterministic policy is fully observable, no randomness in nature. We already know what we did in the past when we are in this state, so we act upon it. Okay, but reinforced learning is on a work on the stochastic environment. So the stochastic policy is and probability of taking an action while in a state S, means an agent if agent want to perform an action, their action, it will depend upon its state. Then what will do next? It does not comes know what we have done in the previous, or we can say in the past. It totally depend on current state. Okay, now comes to the reward function. What is reward function? The goal of the reinforced learning is defined by the reward signal. It could be a positive or it can be a negative. At each state, the environment send an immediate signal. At each state, when an agent perform an action, the environment send an immediate signal to the agent. The signal is known as reward signal, and this reward signal could be a positive or it can be a negative. These rewards are given according to a good or bad action taken by the agent. The agent main objective is to maximize the total number of rewards for the good action and to minimize the, or a reward signal can change the policy. Such if an action selected by the agent lead to low reward, then the policy may change according to the algorithm. Now next is a value function. A reward indicates the immediate signal for the each good and bad action, whereas a value function specify the good state and the action for future. What is the good action according to the current stage for the future? The value function is based on the reward. Okay, the value function determine the reward, as without the reward there could be a no value. If we have the no reward, then it could be a no value for our C. Okay, now the next one element of the reinforced learning is model. Model, it can be a model free approach or a model based approach. In model based approach, we have the model which it provide a complete course of actions or future situation before actually experiences those situation, the approaches for solving the RL problem with the help of a model. But in the model free approach, without using a model, we already random nexus nature and so on. The last element of the reinforced learning. Now these are the category of reinforced learning. First one, as we discussed, model based RN, and the second one is model free RL. In the model based RN enable an agent to create an internal model of the environment. But in the model free, it completely use a trial and error approach in environment. The agent perform different action multiple times to learn the outcome. But in the model based RL enable an agent to create an internal model and learn according to the action performing. This, the agent predict the reward of an action. The agent algorithm is also based on the maximize the reward function and so on. Now, how does the reinforcement learning work? There could be an environment. It can be anything such as room, maze, and football. Agent such as an AI robot. So we represent a 3x4 grid, or we can say a 3 rows and 4 column, in which in the S9 block there can be an AI agent. Row is a fixed wall. This is a fire pit, and this is a final destination where an AI agent has to reach. When it will get a diamond, it will get a positive reward, and when it will reach the fire pit, it will get a negative reward. So in the above image, the agent is at the very first block of the maze. The maze is consisting of S6 blocks, which is a wall, S8 a fire pit, and S4 is a diamond block, and so on. The agent cannot cross the S8 block, so it could be a solid wall. The agent can take only a path to reach the final path, S9 to S5 to S1 to S2 to S3 and to S1. So he will get a +1 reward point. The agent will try to remember the preceding step it will take to reach the final step, and to memorize this step, it assign a value to the previous step, like this. When the agent is in the S9 block, it could be a possible 4 action: up, down, left, right. So it can choose a S5 block to move the upward to get the final diamond. It will for remembering the previous step, the agent will drop a value to this cell. Value is equal to 1. Then comes to the S5 grid, it will 1 and another, and will the final destination stay. But what will the agent do if we start moving from the block S1? What will happen when the agent is there at point at the S1 block, and the value of S2 is equal to 1 and the value of S5 is equal to 1? Then which path the agent can follow? Because the value of this one is 1 and the value of this grid is also 1. So which path, with the shortest path, an agent could follow to reach the diamond? So to overcome this problem, we have a Bellman equation which can solve this problem. It will difficult for the condition agent whether he could up or down for each block has same value. So the above approach is not suitable. So there is a Bellman equation. It introduced by the Richard Ernest Bellman in the year 1953, and hence it is called a Bellman equation. It is used to calculate the value of decision problem. It is used to calculate the value. It is used to calculate the value of a decision problem at a certain point by including the value of the previous state. Okay. Now these are the some points which we are discussing in the next lecture, the Bellman equation. That's it for the now. Thank you.